All right. Thank you, Alex. All right, so today what we're going to be working on, or this week I should say, what we're going to be working on is we're going to be working on parallel lines and a transversal. Okay. There are special things that occur when you have parallel lines and a transversal. So given parallel lines and a transversal, you should be able to prove theorems such as alternate interior angles are congruent, vertical angles are congruent, consecutive interior angles are supplementary. Okay. So today's learning objective is you're going to be able to identify different types of angles and their characteristics. So remember, parallel lines are those two lines that never intersect. Okay? They have the same slope. So it doesn't matter how they're turned, doesn't matter the orientation of the lines, right? We can turn the paper sideways, whatever the case may be. It could be going this direction. It's still parallel lines, and we're still talking about those parallel lines. Okay. So the important thing we're going to cover today are the postulates. And the postulates only apply to angles that are found in parallel lines cut by a transversal. So the things that we're going to be talking about today and tomorrow only apply in this special case, when you have parallel lines cut by a transversal. Okay. Now a transversal, just so you know, a transversal is this line right here that's intersecting both those parallel lines. And you can actually have a transversal intersecting more than one set of parallel lines. It could intersect 4 different parallel lines, and you have to be able to interpret that drawing based on the information provided. But we're going to be talking about corresponding angles first, corresponding angles. So this is one of the definition words that you need to be familiar with. And if 2 lines are cut by a transversal, then corresponding angles are congruent. Okay? Congruent means same size and shape, right? So if we're talking about angles being congruent, we're talking about angles that have the same measurement. Okay? Angles that have the same measurement. And in this case, if those 2 lines, J and K, are parallel, then the following are true. Angle 1 is congruent to angle 5, 2 is congruent to angle 6, 3 is congruent to angle 7, and 4 is congruent to angle 8. So we're talking about corresponding angles. Okay? Corresponding angles mean this one, how it's on the top left side of this line and this transversal. The corresponding angle to that would be in the same location on the other line, top left-hand side of that transversal. Okay? Corresponding. Thus the word corresponding. It corresponds to the same location. So those 2 angles are corresponding. If you look at 3 and 7, 3 is on the bottom left side of that transversal. I think I said right side last time, didn't I? Did I say left side? So 3 is on the left side of the bottom side of that parallel line. 7 is on the bottom side, left-hand side of that transversal. Okay? Same place, different line. Okay? Corresponding angles. Corresponding angles are congruent. Same thing with 2 and 6. Same thing with 4 and 8. David, did you have a question?
Yeah, wouldn't 1 and 4 be congruent?
1 and 4 are going to be congruent, but not because they're corresponding.
What is that called?
We'll talk about that in just a minute. I don't want to get too far ahead. We're going to get to that though. Okay. All right. So if these two lines are parallel, and if you look at these 2 lines, they're marked parallel. That's how I know they're parallel. They didn't tell me they're parallel. In geometry, you have to not assume what's going on. Either you have to be told something is true, or you have to be shown something is true. Okay? Before you assume. If you look at this, these markings right here got the same arrow, but it's not at the end of the line. These are different types of arrows. This shows that these 2 lines are parallel. Okay? So this indication right here just means that these 2 lines are parallel. Okay? They could have 2 arrows here or 3 arrows here, and sometimes they do if there's more than one set of parallel lines in a diagram. But in this case, there's only one set, so these 2 lines are parallel. So if these 2 lines are parallel, this is your transversal that cuts this parallel line. these two angles would be called what kind of angles?
Corresponding.
David, yeah. Corresponding angles, yes. So these two are corresponding angles. And if these two angles are corresponding angles in a set of parallel lines cut by a transversal, that means these two angles are what, Alex?
Corresponding.
Right? I said they were corresponding. What else do we know about them if they're corresponding in a set of parallel lines? They're congruent. What does that mean?
They're the same size and length and shape.
Okay, so if this one's 120, what is this one?
120.
120. Are these two angles here corresponding? Are they in a set of parallel lines? Jamie, if this one is 45 degrees, what is this one? 45. Tommy, if this one's 145, what is this one? 145. Not too hard so far, right? Fairly easy. Corresponding angles, if you have corresponding angles in parallel lines cut by transversal, they have the same measurement. Here's the second one, alternate interior angles. Okay? Alternate interior angles. This is not the one you were talking about yet, David.
Darn it.
Okay? So alternate interior angles kind of means the same thing. It means what it says. If they're alternate, so they're on alternate sides of the transversal. They're on alternate sides of the transversal, alternate sides of the parallel lines, and they're interior. Okay, interior. So on parallel lines, we have what we call interior angles, which are inside the two parallel lines. We also have exterior angles. The exterior angles would be outside the parallel lines. Okay? So interior means it's between the two parallel lines. Alternate meaning one here, one here. Alternate sides, alternate ends of the transversal and the parallel lines. Here and here. So again, what do we need to know? We need to know that alternate interior angles are congruent. So if those two lines are parallel, and they told us that they're parallel here, and they showed us on the diagram that they're parallel here, then we know that angle 3 would be congruent to angle 6, and angle 5 is congruent to angle 4. Those are alternate interior angles. So all of these words, all the terminology we're going to be using this week is very specific, Chaz. It's very specific, and the words of the angles tells us where they're located. Okay, tells us where they're located, so it's pretty easy to find. All right, so before we do this one, what kind of angles are these? Would you raise your hand for me, please? Yes, Gary?
Alternate interior.
So these two are alternate interior angles, even though the parallel lines are turned. You see how they're turned now? They're not going the same direction as before. They're not going this way. They're going up and down this way. So even though the lines are going up and down this way, it's still a set of parallel lines. It's still cut by a transversal. These are still on alternate ends and alternate sides of the transversal, and they're still interior. And if that's true, then these two angles should have the same measurement. So if this one is 65 degrees, this one has to be 65 degrees. If this one here is 100 degrees, this one here has to be 100 degrees. Okay. Now, what does this mean?
It's a,
Sorry.
90 degrees.
90 degrees. So this box means 90 degrees. If this is 90 degrees, what is this? 90. What is this?
90 degrees.
What is this? Okay. Now we have alternate interior angles. If this is 90, what is this?
90.
Which makes this
90.
and
90.
and
90.
so here I have one 90-degree angle with parallel lines, one 90-degree angle with parallel lines, and if I have one 90-degree angle with parallel lines, guess what happens with all of them? They're all 90 degrees. So if one's 90 degrees, they're all 90 degrees. Did you pick up on that?
Yeah.
Yeah. Alternate exterior angles theorem. Alternate exterior angles theorem. So again, they're on alternate sides of the transversal, on opposite ends of the transversal, and they are exterior. They are outside the parallel lines. They are outside the parallel lines. Okay? So alternate exterior angles, if two lines are parallel cut by a transversal, then alternate exterior angles are congruent. If those two lines are parallel, line J and K, then the following is true. And again, you have to be told either the lines are parallel or shown that the two lines are parallel. So here we have an indication on the lines that shows that they're parallel, and here we have a statement telling us that those two lines are parallel. So if that's true, then angle 1 and angle 8 are alternate exterior angles, and they are congruent. Angle 7 and angle 2 are alternate exterior angles, and they would be congruent. Okay? See how they're on alternate sides and they're outside the two parallel lines? Okay? So alternate interior or inside the parallel lines, and alternate exterior outside the parallel lines. Thus the interior and exterior part of that notation. All right. So if this one is 130 degrees, this one would be 130. If this one is 90, this one is
90.
And if this one is 42, this one would be
42.
42.
I'm prepared. Like I wrote 43 on my paper when I.
All right. So look at this page on your PowerPoint right now. It says use the diagram below, tell whether the angles are congruent or not congruent, and then explain why. So if you look at this, you know that these two lines are parallel. Okay. These two lines are parallel right here. Determine whether or not, well, let's look at 1 and 8. So let's just pick a person at random. Alexis. That was pretty random. So Alexis, you have angle 1 and angle 8. What kind of angles are those?
Alternate exterior angles.
Okay, alternate exterior angles. Okay. Would they be congruent?
Yes.
Okay. Let's go to 11. 3 and 4. 3 and 4. Caroline,
Alternate interior angles,
are they alternate interior angles?
or, I don't know.
What, so give me a set of alternate interior angles there. Give me two numbers that are alternate interior.
4 and 5.
Okay, 4 and 5. That's good. Because those are alternate interior angles. What kind of angles are 3 and 4? Remember I said we're going to use this a lot in geometry. It was a couple weeks ago we talked about this. Do you remember? What kind of a line is this?
180 degrees.
It's a straight line, right? In a straight line, the two angles are going to equal what?
180.
180, yes. So since these are not alternate interior angles, alternate exterior angles, could these still be congruent? They could if this was 90 degrees, right? If this was 90 degrees, these could still be congruent, but they're always going to be supplementary, right? They're always going to be supplementary. They're always going to add to equal 180. So in this case, those two angles are not congruent. So 3 and 4 are not congruent. Why? Because they are supplementary. They are linear pair. We call that a linear pair. Bless you. Okay. 4 and 2. 4 and 2. Zach, what about 4 and 2? What kind of angles are those, 4 and 2? Supplementary. What kind of angles would we call those? I just said it just a moment ago. Can we play back the video for you?
I totally forgot.
They're on a line, right? They're what? They're 180. That's supplementary, but we call this a what? If they're on a line. A linear pair, right? Just remember that. It's a line. It's a linear pair, right? Okay. 2 and 7. 2 and 7, what kind of angles are those, Matthew? 2 and 7.
2 and 7 are alternate exterior.
Would they be congruent?
Yes.
Yes. And 3 and 8? What kind of angles, Jacob, are 3 and 8?
They are a linear pair. Right?
Well, they might be supplementary, but they're not a linear pair because they're not on the same line, right?
So they're supplementary.
3 and 8. But we wouldn't call them supplementary, they're just not congruent. Okay? They're just not
Well,
congruent.
they're not alternate interior or exterior.
They're not. They're none of the above. They're not alternate interior, they're not alternate exterior, they're not corresponding.
Freaks.
They're just not congruent.
So what would you call it?
They're not any of those, so they can't be congruent. Yeah. Yes? Did you have a question? Did you have a question?
No.
Yeah, thought you raised your hand.
I have a question.
Yes.
How about 3 and 7 do they have?
3 and 7, what kind of names would those have?
I'm trying to remember.
Corresponding, and yes, they would be congruent.
You hit me hard there, so. Okay.
All right, one last one, I think, is the last one on this one. This is same side interior angles. Same side interior angles. Now, these angles are not congruent unless you have a 90-degree angle. Okay? That's the only time they're going to be congruent. So they will be congruent sometimes if you have a 90-degree angle. But these two angles, if you two lines that are parallel are cut by a transversal, then same side interior angles are supplementary. So you would have angle 3 and angle 5 supplementary, and angle 4 and angle 6 supplementary. That means that they're going to add together to equal 180, right? 180 degrees. So same side interior is again just what the name says. It's on the same side of the transversal, and they're inside the parallel lines. Same side of the transversal, and they're interior. So 3 plus 5 is going to, angle 3 plus angle 5 is going to equal 180, and angle 4 plus angle 6 is going to equal 180. Okay.
Thought that was the last slide.
No, I didn't say it was the last line. All right. So on your paper, we're going to skip that other one. We'll come back to that later. But on this one right here, it says, on your paper, name 2 angles that are corresponding, alternate interior, alternate exterior, same side interior. And we didn't cover this one. This one wasn't on there. David asked this question. He says, are angles 9 and 12 congruent? And I said, yes, they are. He asked if they were corresponding. I said, no, they were not. That's what we call vertical angles. Okay? So 9 and 12 would be what we call vertical angles. And we call them vertical angles because, well, first of all, they're shaped like a V. But these two angles share the same vertex, but have no common sides. Tommy? These two angles share the same vertex, but have no common sides. If you look at this, these two sides here for this angle are different than these two sides here in this angle. So these two angles share a common vertex, but no common sides. That's what a vertical angle definition is. These two angles would be congruent. So 9 and 12 would be vertical angles. 10 and 11 would be vertical angles. 13 and 16 would be vertical angles. And 14 and 15 would be vertical angles. They share a common vertex, but no common sides. Okay? And vertical angles, there's only one thing you need to remember about them, and we talked about this earlier in the year, is vertical angles are always congruent. Always. They're always congruent. Yes, Dave?
Same side interior, is that like 13 and 14 or?
It would not. Same side interior, right? Same side of the transversal, but inside the parallel lines. Same side interior. See, these are not on the same side of that transversal. They're supplementary still, right? So they are still supplementary, but they're not on the same side of the transversal. So angles that are corresponding, angles that are alternate interior, alternate exterior, same side interior, and vertical angles. Make a list. List those down for me, please.
Do we have to like list all the angles?
Yes. On your paper, well, name 2 angles that are.
Okay.
Name 2 angles that are for each one. Okay. So one pair of angles that are corresponding, alternate interior, alternate exterior, same side interior, and vertical. Yes.
Can I get a tissue?
Pardon me?
Can I get a tissue?
Yeah. you already write them down?
Mm-hmm.
Okay, good. So Chaz, give me one set of angles that are corresponding.
9 and 16.
9 and 16 would not be corresponding. 10 and 11 would not be corresponding. Do you know what corresponding means?
12.
Don't just guess. Do you know what corresponding means? What does corresponding mean? Pardon me?
Same.
Same what?
Same side. Same something.
Okay. Go back and read the definition of corresponding angles. I'm going to come back to you in a minute, okay? Go back and read it. I know you're not paying much attention today. So Caroline, give me a set of alternate interior angles.
12 and 13 and 11, 14.
Pardon me?
12 and 13.
12 and 13 would be. Alexis, give me another set of alternate interior.
One of them.
Alexis, give me another set of alternate interior. She said 12 and 13.
I'm lost. Would it be like 12 and 15?
12 and 13 was one.
Then 11 and 14.
11 and 14 would be the other. Okay. Alternate interior, alternate sides of the transversal, inside the parallel lines. Okay. So 12 and 13, 11 and 14. Alternate exterior, David.
Alternate exterior, 9 and 16.
Okay, stop there. Paige, give me the other set.
10 and 15.
10 and 15. Tommy, give me a set of same side interior.
11 and 13.
11 and 13, what do you know about same side interior?
They're on the same.
Yeah, what else do you know about them? Are they congruent? No. What are they?
What is that word?
Snakeskin?
Supplementary.
Supplementary, very good. They're supplementary, yes. And give me a set of vertical angles, Anthony.
9 and 12.
9 and 12. Give me another one, Matthew.
10, 11.
10 and 11. Give me another one, Alex.
14, 15.
14, 15. Give me the last one, Kirsten.
I only have the 9 and 12.
I know, pick a different one. We have 9 and 12. We have 10 and 11. We have 14, 15.
16 and 13?
16 and 13. There you go. Okay. Now you know how to determine what angles are congruent in a parallel lines cut by a transversal. Chaz, give me a set of corresponding.
10, 16.
Okay, did you read the definition
Yes, I
again?
read the definition.
What did it say? Read it to me, please.
The definition says, if two parallel lines are cut by a transversal, then the corresponding angles are congruent.
Did it give you an example of corresponding angles?
Yeah.
Okay, which ones are they?
8 and 4.
8 and 4. Does 8 and 4 look like 10 and 16?
Yeah.
Look closely.
I am.
8 and 4. Do they look like 10 and 16?
Yes. They look like 10 and 16.
Eight and 4. 10 is here, 4 is here. So this 4 and 8 look like 10 and 16. Okay, thank you. That's all right. So, because I just want you to understand what it means, right? That's really the key. It's just to get you back to look and determine what the answer would be. So, now, which two angles would be corresponding?
10 and 14.
Yes, 10 and 14. So that would be good. So excellent job. 10 and 14 would be corresponding. And again, corresponding, if you think about the words, right, they correspond to the same location but on the other line. So initially, you gave me 10 and 16, and they are on opposite lines, but they're not in the same place, right? If you notice, this 10 is above the line, and the 16 is below this line. So it would be 10 and 14, right? Same place. Corresponding, they correspond to the same place, but on a different line. So Caroline, give me another set of corresponding angles.
9 and 13.
9 and 13. Jacob, give me another set of corresponding angles.
Me?
Yeah.
12 and 16.
12 and 16, there's one set left. Ms. Krebs?
What are we talking about? Corresponding, right?
Yes.
11.
11 and 15. 11 and 15. Stay in the moment, right? Stay in the moment.
Well, I don't know which one you guys said.
That's right. That's why I stay in the moment. All right. All right, so that's the end of that PowerPoint. So let's go on to the next one. Stay in the moment, Janice. Try to stay awake with me, okay? I understand. Try to stay with me.
Start counting down the days.
All right. So before we said, here are parallel lines cut by a transversal, right? Here's a parallel line cut by a transversal. Now we're going to be talking about a converse, okay? So given parallel lines and a transversal, I will be able to prove theorems such as alternate interior angles are congruent, vertical angles are congruent, consecutive interior angles are supplementary. So same type of thing, but today's learning objective is you're going to be able to use the converse properties to prove lines parallel. So just a moment ago, we talked about having parallel lines cut by a transversal. Now we're going to be talking about the converse of that, where we have lines or angles that might be congruent, and because those particular lines are congruent or angles are congruent, it makes those lines parallel. Okay? So on your paper, naming two angles that are congruent, explain why, not congruent, explain why. So just to alleviate any confusion, we did this just a moment ago on the other paper. So we know that 10 and 11 are congruent because they're vertical angles. We know that 10 and 16 are not congruent, right? Jazz talked about those, 10 and 16. Those two are not congruent. So 10 and 14 are congruent. 12 and 16 are congruent, they're corresponding. 11 and 14 would be alternate interior. 9 and 16 would be alternate exterior. So all those are congruent. So what is a converse? When you switch the if-then of a statement, it's the converse. Example, if I live in Tucson, then I live in Arizona. Now, sometimes the converse is always true, and sometimes the converse is not true. If I live in Tucson, then I live in Arizona. If I switch that around as the converse, and I say, if I live in Arizona, then I live in Tucson, that's not true. First one would be true. If I live in Tucson, then I live in Arizona, that's true. If I live in Arizona, then I live in Tucson, that's not necessarily true. Okay? It may be true, but it doesn't have to be true. Yes?
What if? Never mind.
All right, converse in geometry though. Converse in geometry. Sometimes converses are true, sometimes they're not true. I just showed you an example of when that's possible. In geometry, we use some that are always true in proofs. So in geometry, we're using the ones that are always true. So think back and write out what is corresponding angles postulate, right? Corresponding angles postulate says if two lines are cut by a transversal, then the corresponding angles are congruent, right? Corresponding angles would be D and B, C and A. If parallel lines are cut by a transversal, the corresponding angles are congruent. Suppose the two lines are cut by a transversal and a pair of corresponding angles are congruent. Are the two lines parallel? And the answer with that would be yes, they would.